Okay, in this video, we will see the configuration and the security measure of the shared storage account. This is actually the bash scripting file I have used to create the storage account, the virtual network, and the virtual machine. Because in this storage account, we disable the public endpoint of the storage account, so we are unable to access this storage account through internet. Instead, we use private endpoint, and that private endpoint will be connected or linked with the virtual network, and in that virtual network there is a virtual machine. So services only in that virtual network is able to access the storage account, rather than any devices or services in the internet is unable to access, because the public endpoint is disabled. The public endpoint is disabled. We can see the architectural representation of this project here from the internet. The public endpoint is disabled so that any request would be restricted. But this is the Azure backbone network, and so the private endpoint is enabled for the storage account. So this is a virtual network linked with the private endpoint, and this is a virtual machine, this virtual network under the subnet. So this virtual machine is able to access the storage account. So in this storage account, data that's going to be stored in this storage account is very sensitive. So I want to control the full process of the encryption. That's why I created customer managed key instead of using platform managed key. I want to get the full control of the encryption. So the data transfer from the source to destination would be encrypted using customer managed key instead of using AES or advanced encryption standard 256, the default algorithm. So the first configuration is public access level. That means disabling public access level. So that means anonymous access is disabled, or to access the storage account, authentication is must. The other is access control. So in access control, we created private endpoint and disabled the public endpoint of the storage account. So this is a storage I have created for this project. This is a shared storage account. So in the networking section, we will see the public network access level. Here it is disabled. Enable from all network is unchecked. That means we are unable to access this storage account through the internet. So how we can access this storage account? By using the private endpoint. I have created the private endpoint. So through this private endpoint, only virtual networks linked with this private endpoint is able to access this storage account. So I have created virtual network. That virtual network secure VNet under secure subnet. We can see the file here. The VNet is here, AZ network VNet create. So the name is secure VNet and the subnet is secure subnet. So in this way, I have created the virtual network in the subnet. Then I deploy the virtual machine in this subnet. So that the virtual machine is able to access the storage account. I have generated the SAS token here. This is a SAS token. Let's check whether we are able to access this storage account or not. Let's check from first the internet. This is my device. Obviously, I would be unable. Here, authorization failure. That means no one is able to access this storage account except those services with linked virtual networks with the private endpoint. This is a virtual machine. This is a virtual machine. Under virtual network, we have linked with the private endpoint. So obviously, we can access the storage account through this virtual machine. Here, we are able to access. This is the blob under that storage account. We are able to access this blob because the private endpoint of the storage account is linked with the virtual network, and this virtual machine is in that virtual network. So this virtual machine is able to access that storage. Okay, this is the way how we can configure the private endpoint for secure access. So the third configuration is security measure. As I told you, I have created customer managed keys, CMK, instead of using platform managed key. By default, in Azure, data is encrypted using platform managed key. But the full control for that key is for the Azure, not for us. But if we want to store sensitive information and we don't want other parties to control our encryption process, we are able to create customer managed key. We are able to create customer managed key, and this is what I did so. So let's see how I can configure uh, customer managed key. I have used Key Vault. Key Vault is a service in Azure environment to store sensitive information. So here I didn't use Microsoft managed keys. Instead, I use customer managed key, and this is the way how we encrypt the storage account for the data that's going to be stored in a storage account. So data will be encrypted not only at transit but in flight also. So here is the key vault, and I created a key here to encrypt. This is key encrypt one to encrypt data. I generate one encryption key, and in this way we encrypt the data, so no one is able to access that data rather than authorized users, or it's unreadable for uh, unauthorized users. When we create customer managed keys, that means the full control is in our hand. We can revoke this encryption key if data is compromised, and the data will be inaccessible for those users, and we can rotate in any time based on our need and requirement. So this is the way how I create customer managed key. The other is blob versioning. That means when we modify or when we delete blobs from this storage account, and the current version, sorry, the previous version will be stored, not automatically deleted or permanently removed from the storage account. The blob version feature is able to store the previous versions of blobs. So here how we can configure this blob versioning under storage account, under data protection, we can see the blob versioning feature is enabled. Here the blob versioning feature is enabled when we delete or when we modify any blob from the storage account. We will get it from the blob versioning feature if you want to get the previous version of the blob. So the other is performance and availability. Here it is hot access tier. That means this tier is for frequently accessed data, and the redundancy option is GRS. The redundancy option is GRS. So we can see it under configuration. Here the blob access tier for this storage account is hot. That means data stored in this storage account is highly accessible or frequently accessible by users. And its redundancy is GRS. That means we will replicate the data in secondary region. Here it is GRS, but if we want to change it, we can change it to read access georedundant storage. That means allowing the read permission for the second storage without initiating failover. So this is the way how we configure the blob service and its security for this project.